Welcome to Internet Society India Hyderabad chapter. Good morning, good afternoon, and good evening to all. It is 11:30 a.m. here in Hyderabad, and it is beginning of summer here. India has as many as 7 chapters in the country. Maybe the only country which is having so many ISOC chapters. All chapters in the country together run INSIG, India School on Internet Governance. This school runs every year in different cities of India for 4 days. We also have IIGF, India School on Internet Governance, with its annual editions led by the Government of India. Well, India contributes hugely in the IT domain. Indians are leading the giant IT companies in the world. A few of them are Microsoft, headed by Satya Nadella, Google, headed by Sundar Pichai, Adobe by Shantanu Narayan, IBM by Arvind Krishna, Micron and SanDisk by Sanjay Mehrotra, World Bank by Ajay Paul Singh, YouTube by Neil Mohan, and PepsiCo by Indra Nooyi. These are all very few of them, but it runs into tens and hundreds in detail. And so then India has invested heavily on digital public infrastructure, and we are reaping the benefits now. Our Hyderabad city is the capital of Telangana state and is the most happening city in IT and digital transformation. ISOC in Hyderabad was chartered on 10th of April 2021. It is 3 years now. The charter runs with a governing board, an advisory board, and 10 functional chairs. SIGs, special interest groups on internet forensics, and IPv6 are in the formation stage. Uniqueness of Hyderabad chapter is ISOC academic hubs, Internet Society academic hubs. We have 10 academic hubs in the universities and engineering colleges now. Preparations are on to enter into the high schools this year. We are also planning to enter the corporates with ISOC enterprise hubs. We are organizing a seminar on DNS security on March 30th, 2024 this year at Microsoft campus with over 300 delegates from our academic hubs. ISOC Hyderabad is an ALS member of APRALO, ICANN. So in collaboration with ICANN, we will be doing an awareness program on universal acceptance on April 26th this year. ICANN will also do series of workshops for us on DNS security. Our chapter has hosted INSIG 2022 and organized remote hubs of APR IGF and local hubs of IGF. A few of the events of our chapter are Future of Internet Workshop, Workshop on Universal Acceptance for Globally Connected Internet, Workshop on Internet Measurements, Global Routing and Online Privacy, Webinar on Community Networks, and INSIG 2022 at IIIT Hyderabad. These are all few of the projects and our plans. Now I invite Mr. G. Srinivas Reddy, the speaker, to deliver his webinar on connected devices. Thank you.
So, thank you, Mohan Garu, for such a very good introduction about ISOC Hyderabad introduction, and then moving into today's webinar on connected devices in the era of Industry 4.0, where actually, so we will be really looking into multiple aspects of Industry 4.0. And let me open the presentation. Let me share the presentation. PowerPoint presentation is appearing, Mohan Garu.
Yeah, it's visible. Yeah.
Okay. So actually, so the topic so very much connected with IoT and M2M. So Internet of Things and machine-to-machine communication. And before going into the connected devices and its case studies and application, just to have a little bit background on the terminology that we will be using, looking at multiple audience who are going to use the connected devices across the industries. The key terms that we talk about, layer. So layer in the context of network layers, especially when we are talking about any of the communication, will be having a layered architecture. In each of those layers, we'll be having protocols, the respective protocols. If we take the models, OSI model, 7-layer model that we'll be having, and then TCP/IP model, we'll be having 5 layers. And similarly, now with the recent updations and the upgrades in the layered model, IoT and M2M have got a 4-layered model, and those layers will be talking in detail in the subsequent sessions. And that is what the layer will talk about particular information that is going to pass from layer to layer, and finally it will be reaching from the physical layer to the application layer, and then the proper communication will be established through the protocols established within that layer. Physical layer, it is more connected with the physical wiring and as well as the bits that we will be passing from one end to another end. And then application layer, more it will be connected with the user, the information consumed by the user or the information passed by the user, that will be keep moving into the next layers. So application layer is the topmost layer, and physical layer is the bottommost layer. And these are the layers that we'll be using in our networking model to basically ensure the data is communicated as intended from end to end over the internet, or maybe on the device to device or mobile machine to machine. These two aspects pretty much will be talking in the subsequent slides. When it comes to levels, the levels will be talking more on with respect to the data that will be passing from one level to another level. Example, when we are passing the data to the devices and then passing the data to the software platform, and then finally it will be reaching to the end user. So these kind of levels will be defining the level of communication that happens in the infrastructure, in the ecosystem. When it comes to the domain, the term, that domain that we'll be using is a set of softwares, layers, and levels of sharing the specific applications and the capabilities. So based on that, we will define the domain, in which domain actually, so we'll be, example, if you take core network is the domain where access network, services capabilities, and as well as the applications can be considered as one domain. So this entire thing will be saying as one domain. This is the network domain. Similarly, the gateway refers to the software for connecting two application layers, especially one at the sender level and the other one is the receiver level. So when we are communicating, both sender and the receiver, they'll have to be in sync so that they can understand what they are communicating. For example, if you take application layer, gateway. Okay, so this is pretty much connected with the application layer. Similarly, when we go to the other terms like IP, this is pretty much important. We need to understand in the era of internet that will be everywhere. Internet is proliferated, and the versions of protocol that we'll be using, internet protocol that we'll be using. Earlier versions, version 4, and then IPv6 is prevalent now, and slowly moving towards IPv6, which is really going to change the way that we communicate on the internet. Okay, so the internet protocol. So especially the version 6, version 4 is a difference that we'll be having. Those differences also makes an impact when we are using the internet for the communication. Then header is the normally any of the data that we'll be sending. We need to have header which will communicate what we are communicating, where we are communicating, and how we wanted to connect. So these are the bit level that we'll be talking. So octets containing the information about the data being sent. So what data that we are sending, and header packets, especially it will be having the more details related to the subsequent segments that are there in the data packet that we are going to send across the networks. So when it comes to the other terms like UDP, so user datagram protocol, now actually we are calling universal datagram protocol, or similar to the TCP/IP. TCP is the transmission control protocol, right? The UDP, especially the user datagram protocol, that similarly protocol data unit is another aspect that we'll be bringing in the new concepts. And similarly, we have MTU. So these are the terms are prevalent that we'll be using in the network models that we are going to use. So when it comes to the networking model, the star models and snowflake models and different models that we'll be having, star network model is very prevalent in most of the cases. We'll be using star networking, and it denotes the number of nodes connected centrally, and know how actually so the node to node communication, how it happens, and know what way actually so they can exchange the data as per the protocols implemented. And then master slave concept is pretty much it. So there will be a master and which will be controlling all the slaves, the working processes so that are there on the network. Okay, the master not only processing the data, no, it will be controlling the nodes that are connected to. The slaves are pretty much doing their respective jobs, allocated jobs. So next, when it comes to the ISM band, so this is pretty much important. So when we are talking about the industrial, scientific, and medical applications, we need to know what frequencies that will be communicating over the network. And so as per the regulations, and the regulators will, and as well as many other controlling authorities, so they will look for the bandwidths or the bands that we are communicating. For each of the regions, so we'll be having a specific bands used, especially the European region, and as well as the North American region, and the Asian region will be using 433 megahertz band when we are talking about the IoT, and as well as M2M communication, mission to mission communications. Okay, these are pretty much controlled, and know if anyone is not following so these regulations, and they will be legally prosecuted, and as well as they'll have to face the legal these aspects. So people need to understand what brand that they are using, and know what concepts that they are using. and especially when it comes to the cyber architectures that are coming in today in the current environments. So these aspects need to be taken care, right from the frequency to the models that we are using, and as well as the communications and the gateways and the routers. Every aspect in the pipeline need to be taken care, and those are going to make difference, especially in the internet world. So some of the suggested models when we are talking about IoT and the M2M, so these need to be pretty much taken care when we are talking the design aspect of the communications, and as well as the design aspects of the data, and as well as the the gateways, and as well as some of the applications that we are putting. So these are pretty much the model driven. The model driven architectures are coming in, and those need to be utilized. All these few couple of slides that I'll be talking more on the precursor for the subjects that we are going to discuss. These terminologies people need to understand, the models need to understand before implementing. Otherwise, we will be getting into all these kind of issues that currently even the top companies, the top branded companies are facing with respect to the information security, with respect to the cyber crimes, and with respect to so many other things. They are growing like anything. So that in recent past we are not seeing. Most of these things are happening because of the loose ends, and as well as the leakages that we have in the data level, network level, and the software level, and the application level. So especially the adoption of these new technologies, emerging technologies like IoT and M2M in the internet, on the internet, especially towards the great requirement in Industry 4.0. So these need to be appropriately designed in each of these levels, and those will be will be discussed in the subsequent model that we are talking about. So towards it, actually, the international forums, international organizations, they are putting a lot of effort in defining the standards, defining the protocols, and defining some kind of interfaces for the easy access, and as well as very tightly controlled mechanisms in some of the sensitive data that we are going to use for the different application domains. Especially the IETF, our own forum, actually. So they are pretty much actively involved in these kind of defining the standards, and especially in the IoT side, IoT design standardizations and guidelines. Some of the forums that there other forums also discussing, but seriously taken in the IETF forum, and as well as other forums like International Telecommunication Union for telecommunications, especially the ITUT. So they're also taken up some of the activities related to IoT domains, networking, and transport capabilities, and these aspects they were more looking into. And then other European Telecommunication Standards Institute, and they have taken some of the aspects related to M2M. So especially the machine-to-machine communication, they were more focused. Even recent case also that we can really see how they have filed so many cases on Google and Intel, or maybe if you take any other medias, okay, that they were straight away implementing these concepts, but that are leading to the problems, especially the privacy problems, and security problems, and especially the cyber crimes that are happening. So these aspects are pretty much defined, and as well as not allowing anything that to happen. The open source hardwares and open source softwares and applications that people are developing around open source hardware and software. So initial days, okay, that will be fine when we are experimenting with, but when it has gone to the consumers, okay, and the consumers are not aware of all these things, okay, and they straight away implementing and using that are going to create the havoc in the internet world. So that is what actually. So every international organization defining these standards and guidelines and protocols, and especially in one of the layer I am going to talk about adoption layer. So there they are focused. Other layers are pretty much standard, and they are using it the quite long period. So last 25 to 30 years, I have seen those layers, not much changes. But one adoption layer is one layer that made a difference in the internet world. So we'll be talking more on that in the subsequent session. And the Open Geospatial Consortium, and they are more dealing with the sensors and discovering the sensors and their capabilities and the quality of service and the other aspects. Actually, they are handling with the IoT devices and machine to machine communications that will be happening, right? And pretty much when we talk about the models, the first thing that comes into our OSI model, the 7-layer model that we'll be using right from the beginning, right from the inception. And the slight tweakings have been done in the TCP/IP model, 5-layer model. And now with the emerging technologies like IoT and M2M, and further updations were made, and those updations we'll be talking more on this layered model. I'll be talking in the next slide. Here we can see in this slide, left side, we can see the 7-layer model, OSI model. And then we have pretty much standard model that we'll be using. If you really see the right side, okay, so physical layer and the data link layer pretty much combined in between the data adoption layer. So, this is very, very important. Other layers we know pretty much aligned with the OSI model, network layer, transport layer, and application layer, especially application support layer, and as well as the end user application layer. So if you really look at the right side, the recent modifications that we could see, 4-layer model, 7-layer to 4-layer model, we are pretty much aligned with the internet, and as well as especially the on internet, the different kinds of communications that we will be doing. So based on the need and based on the kind of requirement, actually the people started implementing these 4 layers in the multiple ways, especially the lowest layer, L1. When we are talking about this is pretty much the device layer, and any device having the gateway capabilities, right? And so those are coming under layer 1, especially they are physical and data link layer. So they are combined together and adopting certain things in the layer 2. Layer 2, actually the transport and network layer, actually. So when we are talking about network and transport, pretty much dealing with the packets, right? Transport and network capabilities we were implementing in this layer 2. When it comes to the layer 3, so pretty much because the internet world, IoT and the M2, there is a lot of support services that happens. That's why we have taken this as a separate layer, L3 as a separate layer, especially for the application support layer. Adoption that is happening in the layer 1 has a lot of impact on the emerging technologies, right? So anything that, example, if you take the IoT devices or M2M devices that we are bringing, even the end users are managing their own devices, right? And they are making the support. So in that context, actually, so the support, application supports are, example, if you take today, IoT platform is the platform built by everyone, it's the open source, right? So, example, if you talk IoT platform, any of these top branded companies, they will be having the separate support for that IoT platform support. If you take Google, if you take Amazon, if you take Microsoft or Intel, any of these people, IBM, so they are supporting for these IoT devices and M2M devices. Especially M2M devices, pretty much is the industry oriented, and but IoT is very broader range. Not only the industry and even the end users also experimenting with these IoT devices, and they will be configuring their own devices. They will be manufacturing their own devices, and they will be pretty much defining their own platforms. That is where the application support layer L3 is really playing a key role in the IoT arena. And the layer 4 is application layer, pretty much like applications and their services with the end users that will be really looking at. So a few examples. ITUT is pretty much aligned their reference models, and when they see how they are implementing, actually you can see these points. Okay, ITUT reference model 1, right? It is with the 6-layer OSI model. And it follows some of the R1 device layer capabilities are similar to the data adaption and physical data link layer. Means that reference model, they're taking this way, and again, the reference model 1 and the network layer capabilities are similar to the transport and network layers. Again, this is another aspect that they have brought in ITUT. And again, the reference model 1, the upper 2 layers capabilities are similar to the top 2 layers. Okay, and comparison with the Cisco IoT reference model. This is the reference model 2, RM2. They have built their own way of supporting these capabilities in the IoT reference model. So some of these points are discussed here, and you can see how it is making difference in each of these companies. Okay, so that is where actually the penetration of IoT devices is going pretty fast compared to any other devices earlier we have seen, right? And the device volume is increasing, the data volume is increasing, and especially when it comes to the cloud, okay, with the support of internet protocols, right? So all the capabilities of cloud are utilized in the IoT devices, right? And further, going into little bit comparison and their use cases and applications, especially the IoT and M2M. In our current design principles that we have discussed so far, in our network layer model and as well as the modified models, okay, and when it comes to the concepts and their purposes, and so we have to understand how IoT is different from M2M and how they both can complement each other. And if we better understand their context and their applications and use cases, we can better implement and good solutions for the respective industries. That's why the few terminologies that we need to understand here: the IoT, what is IoT and what is M2M. Okay, these have become buzzwords in the today's emerging technologies, but the real definitions and as well as the intent, we need to understand the intent. Okay, definitions can be evolving, and people will be changing based on the context. But the intent, the basic intent of IoT, basic intent of M2M. Actually, if you really see these two definitions, that brings us the clear understanding. IoT refers to the network of connected devices or things embedded with the sensor, software, and connectivity capabilities together. All this together, actually, so these devices can communicate with each other and with centralized systems. That's why the IoT platforms, why we are calling it IoT platforms. So M2M platforms are hardly talked about, but IoT platforms are prevalent in all the branded companies, right? That is why centralized systems via internet. So that is why internet, our society, internet society is going to play key role in defining all these things and enabling all these things, and as well as some of the aspects that we are going to really fill the digital divide that we have. That also filled through this Internet of Things, okay, enabling data exchange and automation of processes. Today, because of the IoT, we are automating so many processes, so which are rudimentary, and though manual processes are we are doing, not only in the educational institutions or industries, even in the society. So we are doing so many things, so many automation processes actually evolving, and the data exchange that is happening because of the IoT, that is the open source hardware and open source software platforms available. So when it comes to the machine-to-machine communication, M2M, other hand, especially denotes for direct communication between two nodes, the two machines, okay, between two devices, without a human interaction. You see, the previous case, IoT case, even we can have the human interaction also. It's a larger spectrum it covers, IoT. But when it comes to the M2M, it covers only the specific needs. Without manual intervention, machines will communicate to each other. Okay, that is what actually this is another thing that is evolving, the AI, ML, deep learning, and all these aspects are possible through this M2M communications, actually, where minimal human intervention will be there. Most of the things will be handled through the machine-to-machine communications and the machine intelligence, and that is going to be utilized. It is more like end-to-end communication or the point-to-point communication. Okay, so machine-to-machine communications without a human intervention. So in most of the cases, wherever we have such applications, such use cases, we'll go with the M2M kind of architectures and the protocols, and as well as the interfaces and the implementations. Otherwise, for generic any of the internet applications or the internet enabled applications, we go with the IoT. So especially when it involves the exchanging of data or controls, industrial applications, so predominantly we'll see this kind of thing will happen, right? So people will know the exchange of data and the exchange of the commands, that even the machine controls also we use. Most of the recent space applications and the defense applications, many of these applications that when we are looking at, even industrial automation applications or the manufacturing applications, we will be relaying most of the things on the machines rather the humans, right? This is where actually, so this kind of tightly controlled data, tightly controlled commands, right? And command control centers are prevalent and used with these kind of technologies, right? When it comes to the major differences that we can really see, we'll have to see IoT and the M2M with respect to the scope, with respect to the connectivity, with respect to intelligence, with respect to data volumes, and as well as integration. These aspects, when we talk, right, we'll have to really see where they differ. Example, if you take the scope, okay, the IoT scope is very broad. Okay, the ecosystem having the interconnected devices. When it comes to M2M, it's so focused. It's a direct communication between machines. Okay, this is the difference that we need to understand. Otherwise, we always mix up IoT and M2M. So we have to keep this in mind when we are defining the scope of any of problem solving. Okay, whether it falls under IoT category or M2M category. So if we understand the scope, and the efforts are going to be minimized, and as well as the complexities can be handled easily. When it comes to the connectivity, right? IoT utilizes diverse connection options, right? Example, if you take, it can use Bluetooth, it can use Wi-Fi, it can use low bandwidth LAN, and any of these LoRa technologies. Even any radio communications that will happen. Okay, so you can leverage any communication connectivity options in the IoT. But when it comes to M2M communication, we relay and established protocols over cellular or wired connections. Means basically we'll have to see this differentiation. Even many things we can, even whatever M2M is doing, we can achieve through IoT also. Okay, with IoT we need to handle the complexities. But when it comes to the M2M, it's a very simplicity, but they are very specific. Okay, these aspects with respect to connectivity, we need to understand. When it comes to the intelligence, okay, the IoT devices are becoming more and more intelligent because they are learning so while passing the information. Because these IoT devices is more like autonomous, right? And so it can establish connection, and it can communicate, and it can process, and it can do so many things on its own. Okay, that's why the intelligence at the IoT devices is very much established and further evolving. Like device equipped with intelligence and as well as the interactivity. So these devices will seamlessly communicate each other and with the intelligence. When it comes to the M2M, may have limited intelligence and the focus on the data exchange. Okay, why minimum intelligence? Because there we are not going to use any of the analytical tools and processing and many other things that we normally implement in IoT. So M2M is very much simplified to the specific applications, right? Though intelligence is minimal, but more focus on the data exchange. So any kind of data exchange that happens between platforms to platforms and machines to machines and environments to environments, right? So these kind of thing, so more pretty much specific and controlled. So those need to be analyzed when they are exchanging the data. So when it comes to the volumes of data, okay, the IoT deals with the volumes of data. So if you really look at even our mobile phone itself has got so many IoT built in, right? And the data that we consume today in the mobile, the data that we exchange through our simple mobile that is there in our hand, even rings, actually the rings that we are wearing and the watches that we are wearing and the specs that we are wearing, any of the wearables, so you can really see all these are the data points, and the data volumes are huge and continuous data. When it comes to M2M, it involves very simpler data exchange mechanisms. Example, most of the time they exchange the limited number of devices. Okay, there are no seamless number of devices. Deal with the M2M is that itself. It gives machine to machine, means point to point, or maybe the few configurations you may be having more. But when it comes to IoT, there is no limit. It's scalable. So that too open source, and there are specific protocols that you need to, or you can write your own protocols. So that is what the advantage and the volumes of data that we are going to generate with the IoT. So when it comes to integration, integrating with the cloud platforms and the analytical tools and all that, IoT is proven. That is why actually all these top branded companies are having their own IoT platforms. They build to consume the data, to integrate with the other systems, and to integrate with the cloud through cloud, and as well as integrate their analytical tools and predominantly to see what is happening in the outside. I think this is where I will share one of the case study where this kind of impact in the real world data and real world evidence and real world value that we'll be bringing in. So when we are seamlessly integrating with the cloud platform and the analytical tools that we have built across the industries. When it comes to M2M integration, direct integration with backend systems are the if you really look at proprietary platforms and proprietary systems, the scaling is a problem here, right? So because these are specific to the platforms, specific to the backend systems, okay, and yeah, they have got their own applications. Example, some of the industries, so they will not exchange the data. They are pretty much closed. Example, some of the examples that we use, any regulated environments, especially healthcare, pharmaceuticals, or maybe even some of the mission control, defense side, okay, or some of the manufacturing industries, okay, they are pretty much closed, and their specific or specialized systems and specialized backend systems and all that they will be using, and proprietary platforms they build and they use it. Today, even they are so costly, but they go with them. Though the technology, like the emerging technologies like IoT platforms fulfill the same requirement, but still they go with this proprietary M2M technologies, the machine-to-machine communications and the proprietary systems, right? And we have to always take the trade-off based on the use cases, right? When we talk about the use cases and smart home automations and industrial IoT, IIoT, and the healthcare, these are pretty much picking up this IoT. And when it comes to the telemetry, that is age old. Okay, so we know the telemetry when it is started, and utilities management. Okay, the past trends and environmental monitoring, the current trends. You can see, so many of these things still go with the M2M technologies because they are going to be more regulated and they will see some value out of it and some policies and some new way of looking at the societies. These aspects actually the industry is predominantly going with this and using these technologies for the telemetry monitoring and environmental monitoring and the control and these aspects, especially exchanging the data and putting the controls on it. M2M technologies are pretty much filled in with that. But wherever it is open more, so we'll be going with these kind of use cases, the smart homes and industrial IoT, so where simple monitoring is required, and healthcare, where simple diagnostics are maybe simple monitoring, they're also possible. So actually, so those aspects actually they're pretty much picking up IoT. So next, when it comes to the IoT use cases and the M2M applications we talked about, but I'm a little bit deep driving to smart home automation. Okay, this is like smart thermostats. Okay, so olden days thermostat control and all that to actually to be hard coded, hard binded. But now thermostat controls are becoming in every home in the Western world or maybe the Asian world. So people slowly bringing in all these in smart thermostats and similarly security cameras built in everywhere, right? And even today, once upon a time, only in restricted areas you will be having the security cameras, but now security cameras are there everywhere, and we are being watched continuously wherever we are and whatever that we are doing. That is where the privacy issues are coming in. And next one is lighting systems. Lighting systems actually with the recent emerging technologies in the renewable energies, thermal energy, or maybe even if you take the solar energy, wind energy, and hydro energy, the micro hydro energies, and some of the bio energies that people are picking up and trying to generate their own energies at their own respective use points. Okay, this is where the lightings also lighting systems also getting automated. Means where you are producing electricity and use it there itself. Okay, so these some of the concepts, actually, the smart automation that we will be doing at homes, at factories, and as well as in some of the communities. So we are building so those aspects. When it comes to the industrial IoT, especially when we talk about predictive maintenance of the machines, especially in the large manufacturing units, we have implemented so many such predictive maintenance systems. Actually, so especially the I will come to know when the machine is going to fail. And no, I'm not waiting for the machine is going to machine failed and then I'll be looking for the solution. But today I have a solution to predict when my machine is going to fail in the manufacturing unit. I have got the solution. And the asset tracking, earlier might be difficult to track an asset, and today we can track humans, we can track anything, or you can track equipment, you can track anything. So that is across the world. That is what the protocols that we are talking about earlier. Actually, different international organizations, they are focusing on different areas. Optimizing production processes. Actually, this is one thing pretty much in the manufacturing. These IoT use cases are built in. The recent past, we were doing process analytical technology. What we call this as PAT technologies and the SCADA systems, state-of-the-art SCADA systems, and as well as some of the MES, manufacturing execution systems, in where earlier we were using so much tightly connected M2M kind of thing, but now slowly moving towards industrial IoT, and now people getting advantage out of it. So much cost we are saving and so much wastage we are removing from the manufacturing lines. So optimizing the lean technologies are pretty much working now with this kind of industrial IoT technologies. When it comes to the healthcare, a lot of these wearables that I talked about, remote monitoring the patients, remote monitoring of any of the providers, remote monitoring of any of the places that are going to be used for the healthcare. So all these things are transforming. The personalized care is really transforming because of the use cases that we are showing. When it comes to M2M applications, so telemetry and tracking, this is age old, and still with the latest technologies also we are using the same concepts, but the technologies are really helping in telemetry and tracking of the vehicles and asset management, fleet monitoring of the fleet management, and some of the frauds that are happening, the raw materials, and so many other aspects. And the device data, such as the location and the status, is playing very key role in telemetry and tracking. And similarly, utility management. Any of the utilities that we have, utility infrastructure, especially the smart meters of electricity, water, gas, and these are enabling efficiency of the resource management with this kind of applications, M2M applications, and environment monitoring. So today, global warming, all these, especially due to the way that we are doing the agriculture, the way we are industry is evolving, and the pollution that we are producing. Okay, all this is inevitably moving towards the environment monitoring must be there. So that is what the green technologies and the green way of looking at the things. Okay, the environment monitoring. Okay, M2M is playing very key role, right? Through IoT also we can achieve all these things, but the things, the data that is going to be produced by M2M and the exchange of the data and the control of the data is pretty good in M2M compared to IoT. IoT, you can achieve the same thing at the lower cost, at affordable cost. But when it comes to the data that we are producing, the controls that we'll be using for the availability and as well as the authenticity and some of the other aspects that we'll be using, right? And that is not guaranteed in the IoT use cases. Probably, so wherever mission critical, wherever it is very important to adhere to the regulations and ensure ensuring the quality of the data and the decision making that will happen. Okay, there probably IoT is pretty much loosely connected, and still a lot of security issues that we can see, lot of integrity issues